Okay, hello and good evening, all of you. I hope you all are safe at your home. I hope you all are doing good. So, here we are today with an amazing session, an amazing webinar on an amazing topic. And we have an amazing guest with us also. I'll tell you everything. So I hope with all my heart, first of all, I'll welcome you all, and I hope you all are fine and safe at your home and taking good care of yourself. So on this pleasant evening, I, Radhika, Senior Educator at Space India, welcome you all to be a part of our amazing space talks in the wake of COVID-19 pandemic. As an educationist and also as a social responsibility, I don't want you to miss out on your learning, right? Because learning should not stop at any cost, no matter whether it's happening online or it's happening offline. These days we all are, no matter you are in school, no matter you are in college, the classes are going offline. And we also at Space India have started our iAstronomer program online also, and you can have a look at it. So today we are here for a very interesting topic, webinar on a very interesting topic, and that is remote sensing satellites. I know that's very interesting, and you all have a lot of questions for our amazing guest. Yes, I'll tell you everything. So now, to talk on this topic, we have with us one of the brilliant minds of the country, and that is Dr. Prakash Chauhan, sir. And he's the director of Indian Institute of Remote Sensing, ISRO, Dehradun. Yes, everyone. So I know that you already are very delighted to ask your own things. I know you are already filled with a lot of things to ask him. So keep calm. We are just starting. So now, just a brief introduction of space. We at Space are constantly working for the development of science and astronomy in India. I know that science you all have been studying in your school from class 5th, from class 6th, and from like your junior classes. But we need to understand the practical implements of science in our daily lives, right? So, aiming to create a scientifically aware society where idea is to understand science through its practical applications in our daily life. This is what space is here for. So, space is providing services, products in arena of astronomy and space sciences to school, colleges, NGO, corporates, individuals, because science can be learnt at any age, science can be understood at any age, because it is a part of our life. It's not something separate, right? So, from the starting, our trademark have been innovation, passion, total commitment of astronomy, space sciences among the masses. So we all need to learn about astronomy. We all need to understand that astronomy is not something that only science student can learn. Astronomy is something that every individual can learn. Right. So that is why every project you see we conduct is an opportunity for all the people to explore the amazing aspects of astronomy. Right. So now on this wonderful evening, with immense pleasure, I, Radhika Kapoor, on the behalf of Space Family, welcome our brilliant guest. And with us, he's here, Dr. Prakash Chauhan, Director of Indian Institute of Remote Sensing, ISRO, Dehradun. Welcome, sir. It's been a pleasure to have you on the show. Thank you so much for coming.
Thank you, Radhika. Thank you very much. Thanks a lot for nice words. And first of all, I would also like to thank Space India for inviting me on this occasion. Thank you very much.
Yes, so it's all our pleasure. And now we know that you are taking out your precious time for all of us present here. So today's topic is about remote sensing satellites. And if I talk about your journey, and I have been studying about your journey to IIRS, so I've seen that you have joined ISRO first in 2000. You have joined ISRO as a scientist in 1991, and then finally you started working on remote sensing technology for so long. You have been a part of Mars orbiter mission also. You were a part of Chandrayaan 2 mission also, and you have published 100 research papers in like national and international journals. I mean, wow, sir. So please guide us and motivate us that how, a lot of people who are interested in remote sensing wanted to know, the general person who wanted to know what is remote sensing satellites, how can we tell them what is remote sensing satellites, what are.
Sure. Thank you.
Thank you
So,
so much.
can we start our
Yeah,
talk?
sir. Yeah, sir. Sir, yes. All over to you, sir. Thank you.
Thank you, Radhika, and thank you to Space India and to Ms. Pooja Tiwari as well as Aditya for having me over here. What I will do, I will try to share my screen, and then we will go through my presentation, and then in the end we'll take up questions from our today's participants.
Yeah.
So I hope my screen is visible to everyone.
Okay. So,
Can you,
yes.
can you, can you see the presentation?
Yeah, sir. I'm able to see the presentation.
Okay, thank you. So, as has been told by our host, that today we are going to talk about remote sensing satellites, their utility, and what type of applications we can have of these satellites, which can benefit the common man. And all these things we are going to talk during this week, which is basically considered as World Space Week. And many of you may be aware, but those who are not aware, that World Space Week every year is celebrated world over from October 4th to October 10th. So today is the last day. And October 4th, you all may recall, was important because it was the date on which the first human-made satellite, which was known as Sputnik 1, made and built by USSR at that time. Currently, you recall it by a country called Russia. This launch happened on October 4th, 1957. That's why this day is celebrated, or this becomes the first day for the World Space Week. And the humanity entered into the space generation or space era. So all of those people, those who were born after 4th of October 1957, are considered as world space generation people. So all of you are the all the current generation people belongs to the space generation. And then October 10th is also having a significance because on this day, United Nations signed a very important treaty that space will not be used for conflict. It will be only used for the peaceful purposes and for the development and benefit of the society. So on this day, as this day was dedicated for use of satellites for the common man or the societal benefits, we are going to talk about India's remote sensing satellites and how does we, the common man of this country, get benefited out of these satellite systems. So my name is Prakash, and I am currently working at Indian Institute of Remote Sensing, which is located here in Dehradun, and it is part of Indian Space Research Organization. Now, if we talk of Indian Space Program and its vision, many of you must have heard about Professor Vikram Sarabhai. He has been the pioneer of space science as well as nuclear technology in this country. In fact, Dr. Vikram Sarabhai is considered as the father of Indian space program. He was a great visionary who, in the early, in the late 60s itself, realized that the space technology can be used for the benefit of common man. And I quote his famous statement that India should be second to none in the applications of advanced technologies to the real problems of man and society. So with the humble beginning in 1969 or so, we started a very, very, modest space program. And today, with the help of industry, with the help of academic institutions, and state-of-art technologies, after 50 years, we can say that we have a very successful, totally indigenously made, space program in India. Today, we are talking about, Atmanirbhar Bharat, as many of you must have heard. But space program of this country is a shining example, not only now, since almost 4 to 5 decades, that this program is totally homegrown and has been developed by sons and daughters of India by their own hands and by the technology which has been totally developed in this country. We started with a conviction with firm baby steps. We were talking about just now on 4th October 1957 when USSR launched this Sputnik. And India also, these visionaries like Dr. Sarabhai, they started, the vision that India should also have its own space program, and we should use our space program for the benefit of the common man, not, to get into this. Of those days, those years, the Cold War used to be the one of the driving factors for space activity, especially between USSR and the USA. So India started working towards, launching of sounding rockets within 6 years of a Sputnik launch. These were very small rockets. They were supposed to do sounding of the atmosphere. That means these rockets will have a sensor. This sensor, as the rocket, moves up into the atmosphere, this sensor will make measurements about the temperature and maybe the pressure of the atmosphere at different altitudes. And that for doing so, a place was chosen near Trivandrum. There is a small village called Thumba. It used to be a fishing village. And at Thumba, because it was close to the magnetic equator, it was found to be an ideal location to have a rocket launching station at that time. So with these type of small steps, many of you must have seen the photographs of early Indian space scientists carrying parts of rockets on bullock carts and stuff like this. And today we have very highly technologically developed space activity. We're having our own spaceport at Sriharikota. So we started with zero infrastructure, but with the determination of our people, our commitment of the earlier scientists, and the visionary leadership. Leadership is also a very important thing in developing an activity. So the ISRO leadership under the visionary eyes of Professor Vikram Sarabhai started these seeds, and today we have this self-reliant space infrastructure which is in tune to the national development need, and almost you can say we are among the topmost space agencies in the world, along with NASA, along with European Space Agency, along with Japanese space agencies, Chinese, and then Indian Space Agency. These are the top 4-5 space agencies of the world, those who are pursuing the space dreams. So what are our accomplishments in the last 50 years? We have already launched more than 109 satellites, which basically can be categorized into remote sensing satellites, we have communication satellites, we have navigation satellites, and the space science related activities. Many of you must have heard about missions like Chandrayaan 1, Chandrayaan 2, mission to Mangal Yaan, or Mars Orbiter mission. So these missions basically falls into the category of space science and exploration activity, where the main motive is to generate more knowledge about our celestial neighborhood, especially the Earth's moon, as well as about neighboring planets like Mars or Venus. Then we also have these navigation satellites. These are basically satellites which you use daily in your routine life in terms of navigating you across cities, across countries. The mobile phone which you use, has a GPS receiver inbuilt in it, and this receives GPS signal. GPS is a constellation of navigation satellites, which is basically run and controlled by United States of America. Similarly, India has also made its own regional navigation satellite system. It's called Navik, and currently this is almost operational. And very soon you will have the chips in your mobile phone where you will also be able to receive the Navik signals, and you will be able to get information about your location in terms of latitude, longitude, and height from the mean sea level through the help of these navigation satellites. Communication satellites, most of you are aware, they are very useful to us. The entertainment program in your homes through the DTH, direct to home satellite television system, which you receive every day. You watch entertainment, news, and other programs through the help of these communication satellite systems. Large amount of data transfer, information about weather, as well as now high throughput satellites for providing high broadband internet capabilities are also being attempted with the help of these communication satellite systems. And of course, today we are going to talk about remote sensing satellites. Anyway, we will come to the details of remote sensing satellites in subsequent slides. So, as many of you are aware, to put a satellite into the orbit of the Earth, you need rockets, you need transportation vehicles. So India has also developed our own indigenously developed, variants of different launching rockets. We have a very successful, reliable rocket called Polar Satellite Launch Vehicle, PSLV. We have a heavier rocket called GSLV. And then we are also working on, we have also developed another variant of GSLV. It's called GSLV Mark III. These rockets basically, GSLV Mark III, they can carry very high capability, more than 4,000 kilograms of payload into the orbits, as well as they use cryogenic technologies for these purposes. We are also working effectively on the experimental missions, especially what we call as the re-entry into the atmosphere. Many of you must have seen the shuttle launches. So similar to shuttle concept, ISRO is also developing a reusable launch vehicle technology, and many such demonstrations have already been done. We have also launched more than 10 student satellites, and then satellites for different countries. So we are also into the business of launching satellites into space. We have launched more than 300 satellites for around 33 countries or so. And then we are effectively using these technologies, this infrastructure which we put into the space for various applications. So as far as the reach of Indian space program is concerned, I am showing you the journey from the Earth's orbit to Moon's orbit and towards the Mars also. So ISRO has developed now, mastered the technology to put satellites into what we call as the low Earth orbit satellites, the satellites which orbit around 500 to 900 kilometer belt around the atmosphere of the Earth, or you can say around the Earth in polar orbits, or what we call as the low Earth orbits, as well as there is another orbital slot which is called the geostationary orbital slots, which occurs at around 36,000 kilometers from the surface of the Earth. And at this height, these satellites, they become stationary to the Earth. That means if you are in India or in Delhi, to you these satellites at this location will remain stationary. That it happens because the relative velocities of Earth's movement as well as the satellite movements becomes constant at this particular altitude. So most of the communication satellites as well as the weather satellites, they are placed in these geostationary or GEO orbits at around 36,000 kilometers away from the surface of Earth. Then, you have this beautiful natural satellite of the Earth, which we call as the Earth's moon. It is around, on an average distance of moon from the Earth is around 385,000 kilometers. And we have successfully placed satellite systems around the Earth's moon's orbit twice. First in 2008, when Chandrayaan-1, India's first satellite to explore moon, was launched, and successfully placed our satellites around the surface of moon, and large amount of experiments to know the moon surface, to moon surroundings, moon's characteristics were done using Chandrayaan-1 data. And last year, again, we have launched another mission called Chandrayaan-2, which was a follow-on mission, where our objectives were not only to go around the moon, but also descent onto the moon surface and put our lander on the southern hemisphere of the moon, as well as once the lander successfully descended and rover was supposed to come out and it was supposed to do the lunar exploration. However, as many of you are aware, the lunar landing could not be achieved, but we could successfully put our satellite around the moon surface, and still today the Chandrayaan-2 orbiter is going around the moon and collecting valuable scientific data through various type of sensors, including remote sensing sensors. It is generating information about the moon surface. Then, of course, we had this wonderful mission to Mars orbiter, to Mars. It's called Mars Orbiter Mission, and it covered almost 225 million kilometer distance over a period of roughly 1 year or so. So, around the Mars also, Mars Orbiter Mission, which was supposed to work for 6 months, this satellite is still active and it is still working and providing images of the Mars. So you can see our domain, starting from low Earth orbit to the Martian orbits, the presence of Indian satellite systems is there in our solar system. Now, just to come to today's topic, many of you would like to know, many of you may be aware also that what is remote sensing. First, I would like to introduce to you the basic definition of remote sensing. It's very simple. Anything which you sense remotely is called remote sensing. I will give you one very easy example. When you are in home, many of you are in home nowadays because of this COVID pandemic. And if some nice, your mom is cooking some nice recipe in the kitchen, and even if you are in your dining room, the fragrance or the smell of this food will reach to you, and you will come to know that what is being cooked for today's lunch or dinner, not seeing it directly. It's because your nose acts as a sensor. It gets the smell from far away distance. Similarly, when we see each other, we also do remote sensing. But when we try to take our temperature, or when we try to feel each other, we really don't do remote sensing. We try to touch the surface and try to gather the information. So when you touch any surfaces and try to get the information, you don't do remote sensing. But typically, the sensing of Earth's surface or the surface of any other body like Moon or Mars from space by making use of properties of electromagnetic waves emitted, reflected, or diffracted by these sense objects for the purpose of natural resource management, land use, and protection of environment is classically known as remote sensing. Okay? So if you are seeing through a telescope, Mars, which is very close nowadays to the Earth, and in the night, evening sky is very, you can see a bright red spot, that is Mars. That is also remote sensing because you are not coming in direct contact of Mars. You are seeing it through a help of a telescope. Now, sun becomes the most important source of energy for doing any kind of remote sensing. Sun energy during the daytime, it comes through atmosphere of the Earth. It gets reflected from the surface by trees, by streets, by roads, by your buildings, and then it interacts at a landscape level. That means at very large level, the reflected energy goes back, and then if you put a sensor, or in either in a spacecraft or in a UAV, or maybe if you put a spacecraft or an aircraft, this sensor, if it is having an ability to detect this reflected radiation, you can start creating images of the landscape. Okay, so that's how, using reflected energy from sun, you can generate images. Even by a normal photographic camera in your mobile phone also does the same thing, but only the platform is slightly different. It's in your hand. But if I put the same camera on an aircraft or on a UAV or in a spacecraft, it will start taking images of the Earth on a larger dimension. So that's called the reflectance-based imaging. There is another way you can do imaging of Earth's surface or any other celestial body by measuring the emitted energy. Now, what is the difference between reflected energy and emitted energy? Reflected energy is like when you are sitting, in the sunlight, from your body, the sunlight is reflected, and it is seen by a sensor or even normal human eyes. But you see, your body itself has its own temperature. So when nowadays you go to malls or you go to any shops, etc., they do this. They take measurement of your temperature, not by thermometer, because thermometer is, if you use it, has to touch you, but they take it by a infrared gun. So this infrared gun basically also is a classic example of remote sensing. It has detectors which can detect energy emitted by your body, the heat emitted by your body, and your body emits heat not in the visible, not in the infrared, but far infrared part of electromagnetic spectrum. So you need a special detector, and such detectors are called the thermal detectors, which can sense the thermal energy. So similarly, the emitted energy from the earth, in summertime, you will see even in the evening, the walls of your room are very hot because they are emitting the heat which they absorb throughout the day. And if you could sense this heat through a camera system, you can generate the temperature image or the thermal image of an object. So using both reflected energy as well as energy which is emitted by a body, if you can sense it with the help of electronic gadgets, you can generate images of these objects, and this typically is called as the remote sensing. Okay, so we can generate two-dimensional images of the Earth, then we can store them in a digital platform. We can do analysis on these images. We can generate, the road. We can overlay the road. We can overlay the, house information. We can also extract, like in this image, this is soil, bare soil. These are the trees. These are all fields. Like that, many of these features can be interpreted with the help of, humans, eyes, or by using computer-based algorithms. These algorithms basically works on classification technology, and this process is called information extraction. And this information then can be used for various purposes. Just to give you an example of many of you in your high school physics must have heard about electromagnetic spectrum. You must have read about electromagnetic spectrum. This is the spectrum of energy which is emanated by sun, and the sunlight is not limited only to this part of electromagnetic system which is visible, which we sense. The human eyes are responsive only up to 0.3 to, let's say, 0.7 micron or so, but there are other frequencies or wavelengths which are available in as the sun emits light. So you have gamma rays, and then ultraviolet rays, and then you have the infrared rays, and then you also have the microwave rays, which are basically part of the emitted energy from the sun. So if we design sensors which can operate in ultraviolet range of electromagnetic spectrum, we can, even though from human eye we cannot see ultraviolet rays, but using these special detectors, we can detect UV radiation. We can also detect infrared radiation, as well as there are sensors which can detect the microwave or the very long wavelength energies. And the advantage of these microwave energies is, since their wavelength is much longer compared to the visible, these microwave energy can penetrate through clouds. Okay, so what happens if you are seeing only from space, if you are seeing only in the visible IR, a lot of energy gets reflected back by clouds, and you cannot see through clouds. But if you use microwave radiations, then because they have much larger wavelength, these wavelengths can penetrate through these particles, condensed particles which form clouds, and you can image the Earth's surface even during the rainy conditions or even the night time. So this is the advantage of operating in different part of electromagnetic spectrum. So we have sensors which operate from space in UV region, from visible region, in infrared region, as well as in microwave region. And each of these regions has their distinct advantages in terms of identifying objects on the Earth's surfaces. Now, once you have these sensors and you want these sensors to go, collect information about Earth, you can put them in different type of orbits. In the beginning itself, I talked about two type of orbits. One is the polar sun-synchronous orbits. That means if this is our planet Earth, so if we want to go from North Pole to South Pole and put our satellite, so satellite will rotate in this plane, and then below this, it will start doing the imaging. Okay, so this type of orbit is called polar orbit. You can also incline this orbit and then go not pole to pole, but in a inclined manner from one location to the another location. So this type of orbits are called inclined orbits. And then in another way, you can decide that you don't want to collect information from pole to pole, but you want to put your satellite in a orbit which is around the equatorial plane of the Earth. So such type of orbits are called the equatorial orbits. But the problem with equatorial orbits is that you cannot collect information about the north and southern, positions or the southern portions of the Earth, because even if you have a very wide field of view camera on this satellite, it may so happen that the coverage from an equatorial orbit about Earth will be limited to the equatorial region. But from pole to pole, as the Earth also spins, your satellite goes around it and it can give you the global coverage, and you can generate global images of the Earth from one satellite itself. This geostation, the equatorial orbit, is normally used at a distance from 36,000 kilometers to achieve a condition called geostationarity, and mainly for communication satellites or weather satellites, you are put in this geostationary orbit. Okay, now coming to the Indian satellite scenario. As you were aware that the first satellite was made by Russians, and then slowly Americans and Europeans, they started putting these objects. So these satellite systems which we are putting around Earth, they have some purpose. And in this case, when we are talking about remote sensing, the basic purpose is to do the imaging of the Earth's surface. Okay? So through these satellites, you want to take the photographs or the picture of the Earth's surface for various purposes at various resolutions. Resolution is nothing but the capability of satellite to see the finest object. If you have a resolution, let us say 30 centimeter, you will be able to discriminate very small object on the Earth's surface. But if you have a 1 kilometer spatial resolution, then you will be able to see only very coarse information. We'll show you some examples of this. So India started its journey in 1979 by a launch of an experimental satellite called Bhaskara 1 and 2. And then, of course, in 1988, we developed our first operational remote sensing satellite called IRS-1A. And then, of course, with this, we have now series of different type of satellite systems. And recently, last year, we launched a very high resolution satellite called Cartosat III. It has capability of providing, spatial resolution of the order of around 30 centimeters or so from an orbit of around roughly 500 kilometers. So with this type of a roadmap, India has come a long way from 1988 to provide capabilities of Earth-based imaging in different resolutions. We also have what we call the stereo imaging capability. That means, you can see the same area from two different angles. Like the humans have two eyes. Why we have two eyes? If we would have only one eye, probably we would have not got the perception of depth. So we have two eyes which are separated by a distance. And this phenomenon is called parallax. And using this parallax, we can generate from our eyes a perception of depth. So similarly, if you put two cameras on a space platform separated by a distance but looking at same object, you can generate through the help of some mathematics, the height information. So on Earth, you have different type of topographies. You have mountains, you have lakes, you have depressions. So you can generate this topographic information with the help of these such type of satellite images, and we call that as digital elevation model. So we can generate a computer-based elevation model of the surface. If you come to Himalaya, let's say Dehradun, you will start seeing the hills and the mountains of Himalaya. If you want to measure their heights, then you can use this technology to get the topographic undulations on the Earth's surface very effectively from space-based platform. So today we have capability of resolving Earth or seeing Earth from 1 kilometer spatial resolution to 0.6 meter, even now 0.3 meters or so. And then we can see this Earth surface either 24 hours a day using the geostationary satellites, or maybe or every hour or every half an hour using geostationary satellites, or maybe if you have a pole to pole orbit and a swath which is slightly for the order of around 200 kilometers or so, so same area can be revisited after 24 days. This is called temporal resolution. Okay. Similarly, there are other phenomena. I will not go into details of that. Spectral resolution as well as radiometric resolution. So with this, some basic background about the satellite systems. Satellite is like a bus, and the sensors are like passengers. you know so these sensors, they do the sensing, they take the pictures, but to take a picture, as you know, a camera needs to have power. So satellite also generate its own power. You see these two flying arms kind of thing, they are nothing but the solar panels. And these solar panels, they generate energy from the sunlight. And based on this energy which is generated on board, these imaging systems or the camera systems, they get their energy. Like on your mobile, you have to charge every time. Similarly, these cameras, they require energy to operate, and to do sensing. And once they're using their telescopes, you do sensing, these signals are converted into digital signals. And then on board, there is also storage capability. You store this data, and when the satellite comes over a ground station, then satellite also have equipped with a transmitter. They can transmit this entire data to the ground station on the Earth, and these ground stations again converts these signals into two-dimensional images. So there is a lot of image processing and signal processing and data reception is also involved while we operate these satellite systems. So currently we have these are our operational remote sensing satellites as we speak today. These are our assets in the space which India has put. So we have 4 thematic series of satellites. Natural resource, we get inventory, or we get the assessment about our natural resources, because everything which we use on the earth basically comes from nature. You see, the wood in your homes comes from forest. The water I will show you, which you drink every day, comes either from groundwater, or comes from river, or comes from rainfall. So that is also a natural resource. So these natural resources needs to be monitored and managed properly so that we don't waste them and optimally use. This process is called sustainable development. So for using these resources, we should have an inventory. Like in your house, you do inventory of your clothes, your vessels in your kitchen, or how much other stuff you have. So that process is called inventory. The same way, we also generate every year in India the natural resource inventory, how much forest cover we have, how much water we have, how much coal we have, how much minerals we have. And then every year, our country and other countries in the world are also frequented by different type of disasters. So these disaster time also, satellites provide very valuable information. I will show you that. So we have this resource set 2 and resource set 2A, these two satellite systems which have spatial resolution from 5.8 meter to around 56 meter. There are 3 different sensors with different revisit capabilities. Same way, we have high resolution imaging satellites called Cartosat 1, Cartosat 2, Cartosat 3, etc., etc. The data is used for large scale map creation. We need to create maps of the Earth's surface for planning purposes, for infrastructure development purposes, as well as for cartographic, digital map creation nowadays, which you use, let's say, in your Google, etc. So for generating these maps also, very high resolution satellite images are being used. Otherwise, if you start doing ground surveys, it will take years and years, and you will not be able to complete a large country like India. So we have this cartographic series of satellites also currently, providing a lot of high resolution data for updating our maps, as well as for doing the infrastructure planning purpose. Then oceans also cover 75% of the Earth's surface. So to know more about oceans, we also have an ocean series of satellites. Especially those who live in coastal areas, they know the importance of ocean. You get all your fishes, you get a lot of fish food or seafood from oceans, you get a lot of other resources from ocean. Now oceans are being used even as non-renewable energy sources also. And we also have the sensors on these our satellites, which can give you information about wind, which can give you information about sea surface height, which can give you information about the productivity, amount of carbon which is fixed in the atmosphere by plankton. and it produces food, which basically is eaten by fishes. So a food chain is generated, and we can get some idea about fishing zones using these satellite images, and we provide to our fishermen this fishing zone information so that they can go to these locations and do profitable fishing. So that's how we use satellite data even for fishing purposes. And weather and climate is very important. Weather is day-to-day variation of various variables like temperature, pressure, humidity, etc., etc. So weather is very important for each one of us. So using geostationary satellites, we have two satellites, INSET 3D and 3DR in geostationary orbit. Every 15 minutes, we are able to image in the entire Indian landmass and generate information about the weather systems which are developing over Indian continent. So we use our India Meteorology Department, use this INSET 3D, 3DR data in the weather forecast models, and that's how their weather forecasting has improved substantially today as if we compare to, let's say, 5 to 10 years back situation. So this is one particular image, a very high resolution image, which has been captured by an Indian satellite called Cartosat III, which I told you it was launched last year. This has capability to view Earth in around 30 centimeter scale. So now you can see, it looks like as a photograph you have taken, standing over some high rise building. But remember, this is a picture of Earth which has been taken from an altitude of around 600 kilometers or so, and you can see the individual trees. You can see the different buildings, and then this is a stadium and the car moving on the road. So using this type of data, large amount of analytics can be generated even for the urban infrastructure. But if you want to monitor your enemies or your adversaries in your neighborhood, you can also do large amount of defense intelligence based on this type of high resolution imaging that that can help in situations like we have today in remote areas like Ladakh or in Tibet. How the infrastructure or defense infrastructure is being built by adversaries. All this data is now very useful in generating that defense intelligence also for various countries, and the demand for such type of high resolution images is so high that the world, this data is commercially sold. It's not available free of cost to the common public, because it has got large value of monitoring and surveillance. This is also a high resolution, but not that high resolution image of Delhi. Many of you, those who are in Delhi, you can recognize these features. This is our Rashtrapati Bhavan, and then this is North Block, South Block areas, and this is Sansad Bhavan over here. And then you can see these are the trees over here. And this type of imaging is called the panchromatic, because it's in only one wavelength. That's why you don't see the color photograph. If you do start imaging in different wavelengths, in red, green, and blue, you can make this type of natural color composite pictures. Okay, so this type of Cartosat 2 panchromatic camera provided sub 1 meter images of the land surfaces from space. Similarly, this is another example of an Indian satellite. I told you about the problems with the optical satellites, or the satellites which work in the optical wavelength regions, is that during the cloudy season we cannot see anything, but we have this microwave satellite. So this is an image of one of the India's satellite which works in microwave domain. It has a capability to see through clouds, and day and night, even in night, because it has got its own source of energy, it can illuminate the surface of Earth with microwave energy, and the reflected energy can be captured. And this type of images, this is Paris here, this is Eiffel Tower in Paris, and you can see this is the river scene over here, and then all the infrastructure around this river can be seen. You need to have different skills to interpret these microwave images, because they are not as interpretable as our human eyes are versed to interpret the optical images which normally we see every day. So this is another image of this RISAT microwave synthetic aperture radar satellite over Hooghly River in Calcutta. This is the famous Hooghly Bridge over here, and these are some of the boats where the lights are illuminated, and they are all going into this Hooghly River system. So like this type of data is also very useful for different applications as well as for defense intelligence purposes. So having told you about the basics of these type of satellite systems, their characteristics, their imaging capabilities, I would like to spend now another 10-15 minutes on how we use these data sets. So these data sets, especially remote sensing and meteorological data sets, are used in various aspects about knowing about atmosphere, knowing about our climate, knowing about our land resources, water availability, soil degradation, biodiversity losses, ocean phenomena like rise in sea level, destruction of coral reefs, ocean circulation, ocean resources. Then to know about remote areas like Himalaya, where large amount of snow and glacier, they are very much useful for us because when the snow melts during the summer, a good amount of water is generated in our rivers like Ganga, Yamuna, and Indus, Satluj, and this water is very useful for irrigation and for drinking water purposes for the humanities. So I'll just go through some quick examples. So many of you may be aware about the Sustainable Development Goal of United Nations. So these Sustainable Development Goals are essentially addressing the sustainable use of natural resources for socio-economic security like food, water, energy, health, shelter, infrastructure, information to all by 2030. And then similarly to reduce the risk by different disasters as well as for governance purposes. So in all these spheres of these applications today, we are using the satellite-based information in a very effective manner. So first we will talk about water. Without water, nothing is possible. Life is not possible without water. And the planets around us like Mars, Moon, Venus, none of them have flowing water, and that's why there is no thriving life on these planets. Only we are the unique planet in our solar system which has been blessed by abundance of liquid water and blessed by the abundance of variety of biodiversity in terms of human life, in terms of animal life, as well as in terms of plant life. So the basic core for sustaining life is water. Without water, nothing is possible. So we can get valuable information about water resources. We can get information like for India, Himalaya is very important. Every year during winter, large amount of snow precipitation happens, and during summer, the snow melts and it provides water to the different rivers. So we can get information that how much snow is going to melt, how much water is going to get generated. I will show you a video of this mighty Himalaya, which is called now Third Pole, because this is the largest freshwater reservoir after North Pole and South Pole. So just have a look on this spectacular satellite images of Himalaya. You can see the snow-clad mountains over here. Dehradun is somewhere here. And then down the line, you have these big rivers coming out, Ganga, Yamuna, and other things. So these mountains, which are as high as 3,000 to 4,000, meters, and of course you have the Mount Everest, which is roughly 8,000 meters. This snow accumulates during the winter, and this snow starts moving in terms of, ice. So after many years of snow accumulation, ice gets forms, and this ice also starts moving. So at some places you see this long white things here. These objects are known as glaciers, and these glaciers are the places where the mighty rivers originates. And I will show you some examples of these glaciers as has been seen. So you can see there are, thousands of such glaciers in Himalayas, and all these small rivulets which are originating from these glaciers, they generate water. And these water, these streams eventually go into form into bigger river basins like Ganga Basin, Brahmaputra Basin, Indus Basin. And this water is being used to sustain millions of people in India, in China, and in the eastern part also. And this is the roof of the world. It's called Tibet. This is Mansarovar Lake, Rakshastal and Mansarovar, which is very famous place. Many of you are aware. And then on this side is the Tibet region, and these are many lakes over here. This blue things you can see on Tibet. There are a large number of lakes. And here on the eastern side, this is called the Pamir Himalayas, where the south, the other Asian countries are there. And then if you are standing over Himalaya on these heights, then how the India will look like? You see, these are the plains. These are the plains of India. Delhi is somewhere over here. And if you walk over this Tibet, that's how the feel you will get. These are the slopes of Himalaya where we live, and many forest systems are there. And these are the mighty rivers. This is the river Brahmaputra, which is originating from Tibet, and then generating large amount of water starting from Arunachal Pradesh to the entire Assam Valley. And these are the plains which are most fertile, and they get plenty of water through these mountains of Himalaya when the snow and ice and glacier melts. So this is a holistic view I wanted to give you, which is possible by the help of these satellite images if we stitch them together, so that you can get an idea that how water is very important and Himalaya is so important for water availability. This is a high resolution image of one such glacier. Mind you, what is glacier? Glacier is basically snow which gets accumulated over a period of time and becomes ice. You go and see your refrigerator. For some time you have very powdery snow, but later on in your fridge, if you keep the water for a few hours, you will have ice crystals. So the same way, this snow starts, flowing down in the form of ice, and this flowing ice is nothing but glaciers. So these glaciers here, you have the ice body, and then and these glaciers, they come from a height. These are highly elevated areas. This is Ramo Glacier in Ladakh. And then when they come to the lower altitude, this ice starts melting. You can see these blue things. These are nothing but the water bodies. And then this trickle-down effect forms the mighty rivers. This is another example of one such glacier in Himachal Pradesh. There is a lake over here. The water is in solid form over here. It's in ice form. And at a certain altitude and temperature, this ice starts melting. And this type of lakes got formed. And with the help of this elevation, this liquid water then starts trickling down, and many riverlets, finally they meet and they form mighty rivers. When such rivers, they descend into the plains of India. So once you go to Haridwar or Rishikesh, you can see accumulated water from hundreds of such small streams when the river Ganga is coming into the plains of North India. So this is how water in our rivers, especially the North Indian rivers, is originated. So the snow and this ice is very important to us. If we somehow the snow and ice does not remain, all these rivers will become dry, and we will not have water for drinking purpose, for irrigation, and for sustaining our lives. This is one video I want to show, which we made with the help of satellite data. This is about the Gangotri Glacier. Okay, so this is the Gomukh region from where the Ganga originates, and you can have a virtual fly-through with the help of these satellite images of Gangotri. So today, you need not go to Gangotri. I am showing you Gangotri from, what I call as the virtual darshan, e-darshan. Everything is e nowadays, remember. So this is how the Gangotri Glacier looks like. The big mountains, and this is the ice, which once goes down, melts, and the water starts forming. So this is the body of the Gangotri Glacier. Many small lakes are also formed. And then when we go to the higher altitude, this is the fresh snow. And the other side of Gangotri Glacier is, the other glacier. It's called, the Kedar Valley. So we will go to the Kedar Valley now. And this type of, imaging is called, this process which I was telling you is called digital elevation model. So we have generated this digital elevation. This is Kedarnath temple over here, and this is Champion Glacier. A very steep Kedar Valley you can visualize in your computer. You need not go there physically. All the environment is now simulated in computer system with the help of satellite images and with the help of digital elevation information which we have generated from space-based data sets. So on the third side of this beautiful place is called Badrinath, and I will show you how does Badrinath looks like. So there is another glacier here called Satopant Glacier, and when you descend, then River Mandakini, originates from this Satopant Glacier as we go down, down the hill. Okay, so here now you see the river starts originating, and the water from solid forms becomes the liquid form, and this beautiful river system gets generated. And here we have this Badrinath temple over here. So this visualization I just showed you in a very simple way how we can use the satellite data to do virtual, virtual or digital Earth creation and understand different type of processes which are happening on Earth's surface. So using this type of data, now we are able to generate the snow cover maps in different seasons, and how does this snow changes when in the winter snow falls, and in the summer how much amount of snow melts. Based on this we can do calculations and also compute that how much water will be available in different type of river systems. With the rise of temperature, climate is also changing in Himalaya, and you see many of these glaciers are melting very fast, and such type of large lakes are forming. This is one example of an expanding glacial lake which becomes very, very dangerous sometimes. Sometimes these glacial lakes can burst and they can cause flash flooding. Similarly, we also use satellite data for groundwater prospecting also. We'll not go into details of this, but large amount of information in India is generated that where we will get the groundwater. Such type of maps are also being produced with the use of satellite based remote sensing technology. Similarly, to assess the agriculture, now we are getting information about different crops in India. How many crops are grown, in how much area they are grown, so we can assess that what will be the food production. So for policy formulation for government, it is very important to know that how much wheat, how much rice will get produced. If there is a shortage of wheat and rice, we can think of importing or exporting from other countries. So based on this data, remote sensing based inventories are created every year nowadays for 11 crops in India from different seasons. I will not go into details of this, but just to tell you that this is how the individual fields looks like. This red color shows that there is a crop in these fields, and then if you have this brown color or so, that means there is no crop. And accumulating this type of statistics over national level, we can generate statistics about the crop area, as well as how much crop production will happen for different crops. Similarly, we are also using this technology for crop insurance purposes. You see, during adverse weather condition, large amount of damage happens to the farmer's crop. So many of these farmers are now insured, and many insurance companies wants to know that how much damage has happened to their crops, so that they can settle their insurance claims. So using this type of satellite images also, we can very accurately assess the damage to the crops and also provide this information to the insurance companies. Another natural resource which I told you is the forest system. You see, forests are very important to any nation or even to the earth, because they are the absorbers of atmospheric carbon dioxide. If forests were not there on the earth, our earth would have large amount of greenhouse gases like carbon dioxide and methane. These plants are absorbing the natural carbon dioxide and other greenhouse gases. So if you cut all the forest on the earth, the temperature of the earth will rise substantially, and it will not remain a planet where the life can sustain. So that's why it is important. So in India today, we have around 23% of Indian geographical area. Every 2 years, using satellite data, we do the accounting for our forest system. So these are the areas, different areas. Very green means good quality forest, dense forests, then open forest. So these are the forest cover areas of India. And every year, Forest Survey of India creates inventory or such maps about forests using satellite data. And also a very close eye is kept on the regions where forest degradation is happening. So I'll show you a beautiful animation which we have created for last 30 years. You see this area, this was very green in Assam, and slowly with time, people started cutting this forest. And within 25 years, almost more than 400 square kilometer, 47 square kilometer, forest was cut in this part of Assam. So such type of forest deforestation, which is very bad for our environment, we can monitor. And then if in those times we would have used satellite technology, probably some at the ground some interventions could have been done by the forest department. But of course later on we have seen such type of devastating effects of forest deforestation in Assam. So this what I'm showing you, that now we have archive of satellite data of last 30 years. We can create this type of what we call as the time-lapse technology shots. So whatever has happened in last 30 years, I am able to show you in 30 seconds. So similarly, how the land use and land cover has changed in different parts of the country, we can assess with the help of satellite observations. Similarly, large amount of forest fire occurs every year in Himalayas. We are keeping a close eye on forest fires. You can see this is the fires, live fires we can see from space. And then we tell this information to the forest department so that they can go in time and precisely locate the fires and then douse these fires so that we don't have environmental degradation to our forest during this forest system. Similarly, using our geostationary data, we can also keep an eye on cyclones. Cyclones have very devastating, this thing. So this is a one cyclone, Fani cyclone. You can see how does it propagate, and when it hits the coast, this type of prediction is nowadays done by India Meteorology Department with the precision, and large amount of human lives are saved because of this devastating effect of cyclone. Because we are having a forewarning capability to inform people when cyclone is going to hit. Similarly, once the cyclone has gone, it creates large amount of flooding. And we can map this flood affected areas and tell to the local administration, look, at these villages are flooded, please do something for them so that people can be evacuated. So this is another application of satellite technology. If many of you are living in Delhi, this time, October, November is very bad for Delhi and the North India region because of the air pollution. What I show you here, the air pollution levels in 2017-18, this type of large amount of burning of crops is done in Punjab. So this is, you can see over here, very bad air quality across Pakistan, Punjab, Indian Punjab, Haryana and Delhi, simply because large amount of dust and large amount of crops are burnt. And such a large area we can see from space has very bad air. And situation was so bad in 2017, many of you must have seen, this is the field photograph of Delhi. But it's not Delhi, it's the entire North Indian plain, because of some of the practices which are done by people, is suffering. And most of the time this pollution travels all along the Indo-Gangetic belt. So Delhi comes into news because there's a lot of media in Delhi, but in fact the people in Punjab, Haryana, they're all suffering. And we can keep an eye on this type of pollution, from space. So this is another, pollutant like smoke, which we could detect from space during the forest fire season, and we provide such products and give it to the pollution departments of the country. Similarly, last thing I would like to cover, that during the disaster scenario also, space data is very important. And this is the recent example of floods in Bihar. What you see in the dark blue color is the natural normal water conditions in the rivers, and what you see in the light blue color is the flood map, the flood inundation areas during the heavy monsoon period this year. So if you are at one location, it is very difficult to know, suppose if you are sitting in Patna, that what is happening across Bihar. But you can see from this type of quick images, rapid assessment is done, that which are the areas which are affected by the floods across any state, and then depending on the severity and the population strength of that area, certain rescue relief operations are nowadays planned by NDMA based on this flood maps. There is a high resolution flood map of a village. You can see this is before flood image, and this is after flood. Even the electric poles and then some of these houses, etc., they're all underwater. And this type of data in time, if we provide to the those who are doing governance in this area, this data is very useful for saving large amount of human lives. So that's what I was trying to say, that the satellites are nowadays helping humans to have a very good lifestyle. Similarly, for drought monitoring also, we are using satellite data sets. ISRO is continuously making endeavors to keep these space-based assets in space. We are now planning very advanced satellites. The GEOS imaging satellite ISRO will provide 50-meter spatial resolution images of India every 1 hour, so that whatever is happening over India, we can keep an eye. Similarly, along with NASA, we are developing a synthetic aperture radar science mission. It's called ISR mission, and it will be very useful for various natural resource assessment, like forest, for forest fires, for oil slicks, even for earthquake and landslide activities. This satellite will provide very useful data sets. For students, those who are interested in knowing more about remote sensing, ISRO is also into capacity building and education. At IIRS Dehradun, we have MTech, MSc, and PG diploma programs dedicated to the use of geographic information system and space-based remote sensing technology. We also have one United Nations affiliated center for space science and technology here, which also provides, to our foreign students, a very high quality education in the field of remote sensing, GIS, and geoinformatics. With this, I would like to thank each one of you by ending by this particular slide, which shows that space is touching all spheres of life. We are helping fishermen, we are helping farmers, we are helping our folks in cities and villages by providing information about groundwater sources. We are also helping satellites, communication satellites are helping for medicine, providing, connectivity to the doctors in the rural areas, so that the rural population can get health information, tele-education. Right now, of course, we are doing it through internet-based things, but many of these systems are also in remote areas operate through satellites, and of course, for disaster reduction. It does give large amount of satisfaction to people like us, those who are involved in this business. But still, a lot of work is to be done, and we look forward to our younger generations like you to take these technologies to a higher dimension, so that we can solve the problems of our country, and this country can become a fantastic place to live in future. Thank you very much. Thanks a lot for your patience here.
Thank you so much, sir. It's been pleasure for all of us to listen to you, and you have explained everything in so layman language that every one of us sitting here with the common examples, you have told us everything. It's so amazing, sir. Sir, our students have some questions for you. It will be great if I can ask.
Yes, sure. Please go ahead.
Yeah, so sir, students who are associated with Space Club and the schools and other students who are known, who came to know about this webinar, they have asked a lot of questions. So some of the questions that I wanted to ask you is that there is one question that we got is, how can we find more about the resources present inside the Earth using remote sensing? And can we predict earthquake using satellite?
Yeah. So the two questions. One is on the resources. So we have a lot of resources on the surface of Earth, as well as there are large amount of resources which are below the surface of Earth. Okay. So we talked about water, in the groundwater form. That is also a very important resource. But there are other resources like mineral resources. Okay. So large amount of minerals which are present in the below the surface of Earth. We get information from space-based systems about the type of geological settings in which such type of minerals can remain present. So a reconnaissance information can come from space-based remote sensing. But there is another form of remote sensing which is called geophysical prospecting. Someday we can talk about it, where we basically use same principles but different type of technologies like seismic energy. We put acoustic energy into the Earth by coming into contact of Earth, and then get reflected signal. That tells you a lot of things about which are the parts of the Earth where, let's say, oil reservoirs are there, hydrocarbon reservoirs are there, mineral reservoirs are there, coal reservoirs are there. So using such type of technology, you can get conclusive evidences. But from space-based remote sensing, you can get a broad idea that what type of lithological or geological settings in which such type of mineral resources can occur. Okay, then second aspect was about earthquakes. So earthquake forecasting as of now, if you listen to many of the seismologists, they say that earthquake forecasting is difficult. It's not possible. But using space-based systems, we can identify areas of the Earth which are under continuous deformation. You see what happens if an area is undergoing an earthquake, or where an earthquake is likely to happen, it starts producing signatures. And these signatures are called precursors for the Earth, precursors for the earthquake. So if you can monitor these precursors, there are many precursors. I will not go into details of that. Temperature starts rising. There are certain gases which starts emanating. There are certain changes which people see in the ionosphere of the Earth. And then Earth's surface starts deforming up to centimeter scales or so. So using now space technology, we can monitor these things, and then using models, we can think of predicting by using this data. So in a way, it can help. But this is still evolving. This is in the research and development phase. But as on now, today, we don't have technology, but we have early warning technologies about earthquakes. Suppose an earthquake has happened, let's say in Himalaya. But if you are in Delhi, there are technology today that 2 or 3 minutes in advance, you can be warned that, look, there is an earthquake has happened, the waves are going to travel, and better you come out of your house and stay, because earthquake is not going to kill you. It's the houses which are not good. If they collapse, then people can get affected. If you are in open areas, earthquake waves will come and go and nothing will happen.
Yes. So thank you so much, sir. And one other question from our other students, that how can a remote sensing satellite contribute for digitalizing Earth, for digital Earth?
Yeah. So as I showed you some examples of very nice example of glaciers, I showed you digital. That's a part of, keeping. What is digitalization? If you have your signature, a digital
Yeah.
signature.
Yeah.
Every time you sign it, but you scan it and keep it, then simply you put it in digital form. So like landforms of the Earth, if I can generate information about the landforms of Earth, what is their height, what is their slope, what is the dynamics. So using this data, you can digitalize that, put it in a digital environment. You can also overlay other attributes like roads, your railway network, your schools, your colleges, and put them together so that if you want to do some decision making, let's say in some area you want to open some new schools. So now you know how many schools are there in this area and which area does not have any school. So using this type of information, decision support system, that will help you in taking decisions. So whatever we are doing with the help of remote sensing and collating all the data together, we are basically digitalizing our Earth. And that's the concept of digital Earth, that every information about Earth surface, activities over the Earth is available on a click of a button to anyone. Okay?
Yeah, right. And last question, sir. A lot of students are asking that they want to learn remote sensing. As you also told that for working professionals, there is a 9-month course available with IIRS also. So some students who are like undergraduate or they are done with their post graduation, they really wanted to make a career in space science. They really wanted to come into learning remote sensing technology. So what is the path? I mean, you
Yeah.
are yourself.
Okay. Yeah, so we, there are many places now in this country, as well as many of the students can also think of going to international universities where the education on remote sensing, geospatial technology is provided. In India, if you talk about, I talked the example of Indian Institute of Remote Sensing. Apart from PG diploma course, we also have a 2 years Master of Technology course, MTech course, where students, those who have done BTech in computer science, electronics, those who are MSc in other science, natural science subjects, they can apply. They can also do MTech. We also have an MSc program with the University of Twente, Netherlands. It's a dual degree, it's a joint program. So that program is also technology development program, mainly devoted towards developing higher technological products using geospatial technology. So that is another avenue for, it's a 2-year program. Then there are a lot of universities in India nowadays are providing master's programs, especially at the post-graduation level in geoinformatics. So if you give a good Google search, you can find those universities. I will not take the names. ISRO also has one more institution. It's called Indian Institute of Space Technology, IIST in Trivandrum. That institute also provides undergrad education after your +2. You have to go through JEE Advanced process, and then you can seek admission there for your BTech courses, as well as there are opportunities to do master's courses also. A lot of our computer science and other students, engineering students, those who are interested nowadays in artificial intelligence, machine learning, spatial analytics, there is large scope for them for going even to universities in India as well as abroad for pursuing these type of subjects, because it's a digital data. And then if you are well versed with the data analysis techniques, you can apply your tools and then get the information extraction. So there is large scope for such such students. And in future, in my view, this will become like a IT revolution we have in India. The geospatial will be a new industry which is going to be there in next 5 to 10 years. So if you develop skills in this field, definitely your employability in the market will be very high.
Thank you so much, sir. It's been a pleasure that you have shared your experiences with us. So, just before ending the session, just want to ask you to say few words about the Space India, because we really need your motivation to continue. So, it will be great if you can say just few words of your wisdom.
Yeah. So I think the Space India is doing fantastically well. In fact, you are all involved in generating large amount of space promotional activities, awareness about the space and how the space is useful for human beings, as well as it's not that we get materialistic returns from space. It also helps you in generating the new knowledge. See, I talked about remote sensing today, where we are looking towards earth, but the same telescope which is lying behind you is also an example of remote sensing. So if you start looking outer earth, you get a wonderful knowledge about our universe. You can get answers to some of the questions, that how universe has been created, how the stars do form, what happens to the stars when they die, how the black hole forms. So a new form of knowledge is also created with the help of these technologies, and Space India is definitely playing its role. You are also, I know that you are conducting large amount of exhibitions. Have a good collection of telescopes. You are taking them, everywhere during special events, and then doing, a large amount of celestial watch events also. So definitely, you guys are rocking. I'll say
Thank you so much,
fantastic.
sir. Thank you so much, sir. So, sir, just before going, just want to ask you last question. We don't want you to go. Actually, just want to ask you a last question. That you have started your journey from ISRO and then ISR, and you were a part of MOM mission and Chandrayaan 2. So basically, we are looking at you as an inspiration. So, sir, what is your success mantra? What are the things you have been following in life that help you to excel in your career, and also in learning about the whole space sciences, which is really a alien thing for a lot of people watching.
Yeah, see, there's people think the science is difficult, but I'll tell you the science is fun. It's easy to understand, because in every sphere of life, we have principles of science. And if we start realizing that whatever we are doing, and if we develop a ability and capability in society to do what we call as the scientific thinking, then science will be pretty easy, because everything is driven by science only. Today, if people are being saved from coronavirus, it is because of the advances in medical science, because we have understood the entire working mechanisms of these microorganisms. And then we know that how to overcome that and which molecules can help us in doing so. So the basic mantra is, whatever you do, it's not that you have to be a scientist. Everybody cannot be a scientist. We need economists, we need musicians, we need artists, we need farmers. But
Yeah.
whichever sphere of life you work with your passion. So if you are passionate towards your work, and if you devote time, and if you generate knowledge or acquire knowledge, the knowledge is most important thing. Every time we acquire knowledge, now if I am speaking with you, I am also acquiring good knowledge. You are also acquiring, others are also acquiring. So keep your eyes and ears open, and do hard work, whichever field you have chosen. Give 100% of your contribution, and enjoy also. See, do work when you are working, and don't think about work when you are enjoying. So if you start enjoying your work as well as your other part of the life, definitely nobody can stop you becoming successful in your life. So that's the only mantra, very simple. Okay.
Yeah, thank you so much, sir. We have no words to thank you. It's been a pleasure talking to you. You have explained us all the remote sensing thing in such an easy words that we get to know a major introduction to whole idea. So thank you so much, sir. It's been a pleasure you being on the Space Talks. Thank you so much, sir. And I
Thank you,
hope all
Radhika.
our viewers. Thank you so much, sir.
Bye bye. Bye.
Bye bye, sir. I hope all of the viewers who are watching us have enjoyed a lot. And I know that you all wanted to learn more and more. So keep yourself engaged with Space India. Keep on learning about the scientific impacts around you. Keep on watching the sky with your telescopes, and of course, do check out iAstronomer Space India Club that is going on. So be a part of that digital revolution of learning astronomy at the comfort of your home. So thank you so much. It's been a pleasure, all of you being here. Thank you so much.
Hello. Yes. हो गया ना? हाँ मैम, स्क्रीन